Identifying transformations that map a quadrilateral onto itself. Okay, so the most important thing that you need to do when you're doing this problem is read these first 4 points, okay? Because sometimes when you're on the computer, your screen can stretch or shrink or manipulate this image somehow so that it doesn't look like it should. So what you want to do is make sure you read what the image is. So in my case, it's a trapezoid, okay? And mine looks like a trapezoid, so that's helpful. Next, it tells you about the lines and the points that it marks on it. So line C, which is this one, intersects these two vertices, which are the corners. Now, we should also make note, it doesn't go through that point in the middle, but it goes through the two vertices. Line D bisects each side it passes through, which means these are the middle points of the sides, and it does, in fact, go through that middle point. And P is the very center of the whole trapezoid. Okay, so those are important things to recognize first. Now, when we look at these questions, it says which transformations must map the trapezoid exactly onto itself. So let's talk about what this means first. When it says must map the trapezoid exactly onto itself, it means that whatever it's saying, the image is going to look exactly like it did to start with. So we're looking for lines of symmetry, okay, and we're looking for rotational symmetry. Because we know, because if it has rotational symmetry, we know that if we spin it, it still will look the same, okay, which means it maps it onto itself. And a line of symmetry is if you fold it and both halves look the same. So when it says a reflection across line C, that's talking about a line of symmetry. Can we fold it on the line C and both halves look the same? So if you picture folding it right here on the line C, would both halves look the same? No, they would not. So this one's out. Don't select that one. Okay? The next one says a counterclockwise rotation about the center P by 90 degrees. So this is counterclockwise, going against the direction of the clock. And we're going to go 90 degrees, which when we think about it is one click over. Okay, one quadrant over. So this point would come up here. Okay, so if you want, you can just imagine clicking it one way over and seeing if it would work. If it helps you to see it on tracing paper, you will have access to tracing paper in our classrooms. So I'll show you both. Now, you can imagine it in your head, but if not, there's my trapezoid, and I'm going to go one click 90 degrees to the right. Did they land exactly on top of each other? No, so this one's out. Okay? The next one says a reflection across line D. So again, reflections are talking about lines of symmetry. So we're going to think about folding it on D and seeing if both halves would match. So if I folded it right there, my halves would not perfectly match. So this one's also out. Okay? Clockwise rotation about P, the center, by 180. So now we're going clockwise 180 degrees. So again, you can just imagine flipping it upside down, or you can do it with tracing paper. So if you go exactly upside down, does that match? It does not. So this one's out. So this answer is actually none of the above. Okay, but I'm going to show you one more quick example of a different shape just to be sure that you're feeling okay about this one. So this one is given a rectangle. Line G intersects our two corners or vertices. Line H bisects each side, which means it's right in the middle of both of these sides. And point Y is the center of the rectangle. Okay? So we need to think about a reflection across the line G. So if I took this and folded this paper in half, would they line up? Now, it looks like it's tempting that they would, but if you start to fold it, you'll notice they're not going to line up perfectly. So this one's out. A counterclockwise rotation 90 degrees about the center. So you can picture taking this and turning it one click up. Or you can get your tracing paper to check to be sure. So again, because it's hard for me to show you what's happening in my brain, I'm going to use my tracing paper. So here's my rectangle, here's my center, and I'm going to go one click counterclockwise. There's 90 degrees. Does it line up? No, so that one's out. Okay? The next one says clockwise rotation 180 degrees. So we're going to take our rectangle, line it back up originally, and we're going to go 180 degrees clockwise. So we're going this way, 180 degrees. Okay, did it line up perfectly? It did. So it does map it onto itself because it looks the same after the transformation. Okay, and a reflection across line H. So if I fold it across this line H, would it land exactly on itself? Would this half match this half? It would. So this is also another choice. And obviously because we picked two, it's not none of the above. So there's two examples to help you figure your own problem out.